The HAL Tejas light combat aircraft is often presented as the ultimate symbol of India's indigenous defense capabilities, but that image hides a critical reliance on foreign technology. The Tejas depends on the American-made General Electric F404 engine for its thrust. This reliance creates a geopolitical vulnerability. If diplomatic relations sour or international sanctions are imposed, the flow of spare parts and new engines can stop, potentially grounding the entire fleet. Real military sovereignty requires a nation to do more than build the airframe. It must be able to design and manufacture the engine from the ground up. In the late 1980s, India's gas turbine research establishment set out to close this gap. They were mandated to build the GTX-35VS Kaveri, a completely indigenous engine for the Tejas. The project became a cautionary tale of aerospace development. It stretched across 30 years of missed deadlines and cost billions of rupees without ever reaching the Tejas production line. Why was a nation that can launch satellites to Mars unable to build a working fighter jet engine for 3 decades? The engineers understood the mechanics of jet propulsion. The problem was that they had run directly into the physical limits of material science. In a turbofan's core, the combustor and turbine operate at extreme temperatures, exceeding 1700 degrees Celsius, while spinning at 15,000 RPM. This thermodynamic bottleneck is hundreds of degrees hotter than the actual melting point of the metals used to build the turbine blades. To survive without liquefying, these blades are grown from a single, continuous metal crystal, containing an internal maze of microscopic cooling channels to bleed heat. Mastering this metallurgy is what separates aerospace powers from the rest of the world. India lacked the foundational material science to keep its engines from melting during high-performance testing. In 1998, India conducted nuclear tests at Pokhran. The international community responded with sweeping sanctions that crippled the Kaveri program. These sanctions specifically targeted India's access to critical Western technologies, materials, and high-altitude testing facilities. The DRDO was suddenly isolated. The resulting engine was too heavy and underpowered. It achieved just 75 kilonewtons of thrust, well below the 81 kilonewtons required for the Tejas, leading to its official delinking from the aircraft in 2008. Instead of abandoning the research, India pivoted. They removed the afterburner to create a dry Kaveri, an engine variant intended for the Ghatak stealth combat drone. This pivot kept the expertise alive. While the Kaveri failed to power a fighter jet, it forced Indian labs to learn the baseline mechanics of jet propulsion, setting the stage for a new strategic approach. That new approach materialized in a massive co-development deal with the French firm Safran to build a 110 kilonewton engine for India's next-generation fighter. This new deal isn't a simple purchase. France has agreed to a full transfer of technology, including the proprietary secrets of the engine's hot section. For the first time, India will have the blueprints for single crystal blades and advanced thermal cooling, the specific metallurgical secrets they couldn't crack alone. Owning these blueprints provides the technical foundation that India's labs spent 3 decades trying to reverse engineer. It identifies exactly how to overcome the material limits that stalled the Kaveri for years. To move these designs from paper to hardware, the Ministry of Defense issued a 2026 expression of interest to find a brand new domestic production partner. Industrial groups like Godrej, the Tata Group, and Hindustan Aeronautics are now tasked with building a high-tech supply chain capable of executing the sub-micron tolerances required for modern Aero engines. The objective is a future where the next generation of Indian air power relies on integrated hardware produced entirely within Indian borders. By mastering the hot section through this partnership, India joins the small group of nations with the strategic autonomy to produce and sustain their own frontline fighters without relying on a foreign